Introducing CHCNav's new ViLi i100 Visual LiDAR GNSS receiver, redefining flagship GNSS with revolutionary innovation. Powered by next-generation 860,000 points per second LiDAR fusion, ViLi i100 accurately captures surrounding 3D spatial data in GNSS-obstructed environments, intelligently analyzes satellite signal paths, and auto-filters multipath errors caused by obstruction or reflection. Even in narrow alleys, dense forests, or near high-rise buildings, it delivers confident and consistent 5 centimeters absolute accuracy. No matter how many times you measure, your position stays right. Once right, always right. With the enhanced SVIX 2.0 engine, ViLi i100 ensures reliable 5 centimeters accuracy within 20 meters, even in GNSS-denied areas. Using high-density LiDAR data with SLAM-based angular constraints, trained on tens of thousands of real-world scenarios, optimized for complex field conditions. No need to switch total stations. Experience true GNSS anywhere, even in GNSS-denied areas. High-precision laser sensing enables real-time 3D point cloud earthwork calculation. With Landstar software, just scan and define boundaries to get 99.98% accurate cut. Fill results instantly on site. No surface contact needed, combining precision, efficiency, and safety in one workflow. ViLi i100 supports ViLiDAR contact with survey using laser data, capturing one photo to instantly extract multiple 3D coordinates with 5 centimeters accuracy up to 15 meters. Capture first, select later. No need to aim, stay steady, or align the range pole, eliminating hand tremors. The 8-megapixel telephoto camera delivers clear visuals even when zooming from long distance. With the latest Landstar software, ViLi i100 integrates all conventional GNSS features in one flagship receiver. CAD-AR visual stakeout boosts efficiency by up to 50% and supports NTREP, UHF base rover, and PPP modes. ViLi i100 Visual LiDAR GNSS RTK receiver. Now, you can trust every fix.
Hello and welcome everyone. If that product video has got your attention and made you curious about the ViLi i100, you are in the right place. I'm Cecilia, your host for today's CHCNav online webinar. ViLi i100 deep dive from core innovations to real-world applications. Now let's bring in our expert panel to say hello to all attendees. Please switch on your cameras. Miss Rachel, Miss Jazz from CHCNav, and Mr. Tad from TreeSight. Let's go around and introduce ourselves properly. So I'm Cecilia, guiding you through today's session. And then next is Rachel, our dedicated product specialist who's led the ViLi i100 market launch. Then we have Jess, the R&D ways behind the device's groundbreaking technology. And last but certainly not least, Tad, the owner of our UK partner TreeSight, who's been putting the ViLi i100 to the test in real-world client projects across the UK. Let's give a big virtual round of applause to our guests. And thanks everyone for that warm welcoming. For those joining us to learn more about game-changing GNSS solutions, let's quickly walk through today's agenda so you know what to expect. First, Rachel will break down the core features of the ViLi i100 that set it apart in the visual LiDAR GNSS space. Next, Jess will dive into the technical backbone, how multi-sensor fusion elevates accuracy even in the trickiest GNSS challenged environments. Then Tad from TreeSight will share real-world application stories from the UK market, so you can see how the device performs in our on-the-ground scenarios. And we will wrap up with a live Q&A section where you can submit your questions and get answers directly from our panel. And let's get started with the first segment.
Okay, so I will share my slides. Yeah, everybody, can you hear me?
Yes.
Okay.
You are in very good signal.
Yeah, thank you. So hi everyone, and I'm Rachel, the product manager of the ViLi 100. And since our ViLi 100 launched in late September, so it has received an amazing response from users around the world. And today we are so excited to take you a little bit deeper, whether you are already know the ViLi 100 or have used it in the field, or you are just starting to explore it. And this session will give you a much clearer and more practical understanding of what it makes it special. So firstly, I will share why we developed the ViLi 100 and what real field challenges we saw and what problems we want to solve for our surveyors. And then I will walk you through the 5 key highlights of the ViLi 100 and why this product has attracted so many attentions globally. So, all right, let's get started. And we know that over the past 30 years, our surveying industry has moved forward with better GNSS tools, portable GNSS receivers to IMU tiered measurement, to fully constellation frequency points, and more recently, we have entered the era of intelligent fusion. We combine the GNSS with the visual technology, laser technology, and also spatial data to push the performance further. Our GNSS receiver has come a long way, but the real question is, have they gone far enough? So because in the real world, challenges still remain, like in cities, the tall buildings block signals, and in old neighborhoods, the narrow spaces cause unstable accuracy, and also in forests, canopy reflection reduce the reliability, and you measure the same point twice, but you got 2 different coordinates. So these GNSS obstructed environments are daily headaches for our surveyors, and conventional GNSS receivers still struggle to solve them. And you can see it gets even harder in GNSS fully denied areas. Under eaves, in underpasses, on construction sites, there is simply no GNSS signal, and our conventional GNSS receiver just cannot get fixed at all. And switching to total stations will take extra time. So what used to be just a measurement gap now turns into a project delay. And also beyond that, the dangerous and hard to reach areas are another barrier. Yes, there have been innovative solutions trying to solve this kind of problems, but they are still far from perfect. Like the laser survey, for example, we aiming at distance point, but even the slightest shake will throw off the target and the accuracy will suffer. So at this time, we often need an additional bipod to assist. And our visual survey would take a photo or video first, but we need to wait on site for the processing. So efficiency, safety, and accuracy, how can we balance all 3? That's the question. And also for our field operators on construction sites, the challenges continue, whether it's earthwork value calculation or stakeout in complex environments. The story is the same: no efficiency, poor accuracy, and also unsafe operations. So GNSS obstructed areas, GNSS denied areas, hard to reach and dangerous site and complex construction environments. They are not edge cases, they are everyday reliability for our surveyors and field operators. This is why we have invested a lot in R&D and innovative to correct these limits of spatial temporal positioning. And finally, we find that through the deep fusion of multi-source sensors, we combining the GNSS, LiDAR, Ultra-MU, and the multi-visual data, we can cross-check the GNSS signal and intelligently filter out unreliable GNSS signals and build a truly robust positioning model. So this is the key to reliable accuracy, even in GNSS constructed and GNSS denied environments. And this breakthrough brings us to today's highlights, the ViLi 100 Visual LiDAR GNSS receiver. So the ViLi 100 is our new flagship redefine what an industry flagship GNSS receiver can do. Like in GNSS obstructed areas, it delivers confident and consistent accuracy. Once right, always right. Where conventional GNSS receiver struggle, ViLi100 performs. And in GNSS denied areas, SFIX2 provides reliable 5 cm accuracy within 20 meters, even where conventional GNSS receiver cannot get fixed. And for construction projects, especially on earthwork value projects, ViLi100 provides real-time 3D-point cloud calculation, accurate, fast, and safe. And in hard-to-reach and dangerous areas, ViLi100 offers ViLi contactless survey, capture points without aiming perfectly or stand steady. Surveying becomes smart and safe. And beyond all these innovations, the ViLi100 remains a fully reliable all-in-one flagship GNSS receiver with every conventional feature you rely on. So with ViLi100, now you can trust every fix. And then let's take a closer look at what really makes ViLi100 different. I will walk you through its 5 key features, key highlights, and the core reason why ViLi100 has such a strong performance in real-world projects. Now, let's talk about the first and most essential feature of ViLi100, confident and consistent accuracy in abstraction. Once right, always right. So in cities, forests, and narrow alleys, accuracy cannot be a guess. It has to be reliable every single time. That's exactly what ViLi100 is designed to deliver, even in GNSS obstructed environments. So how do we achieve that? The biggest challenge in GNSS obstructed area is the multipath satellite signal error bouncing off the buildings, the trees, and obstacles. That's what caused unstable and unreliable positioning. ViLi100 solved this at the source. It features the next generation LiDAR sensor, scanning 860,000 points per second, about 3 times faster than conventional LiDAR-assisted GNSS solutions. And in real time, ViLi100 capture precise 3D spatial data and build a dynamic environment map around you. This is a foundation of stable accuracy. So after we detected the surrounding spatial information, ViLi100 intelligently analyzes the satellite signals in real time and automatically filter out those affected by multipath errors caused by reflection or obstruction. So this is ViLi100's breakthrough multipath auto-filtering algorithm. And our sister engineer Jesse will introduce it later in the next session. So it solved one of the toughest challenges in RTK positioning in inconsistent coordinates caused by the ambiguous fixed in complex environments. So you can see the result: stable, jump-free positioning with confident and consistent 5 centimeters absolute accuracy, either in narrow alleys, dense forests, or near high-rise buildings. No matter how many times you measure, your positioning stays right, and once right, always right. So from May through the September, we launched the ViLi100. We took it on a true global journey, and our teams from R&D, product, and technical support tested it across more than 10 countries and regions, and in cities, forests, narrow alleys, and complex construction sites. Our goal was simple: validate and optimize the accuracy and the real-world GNSS conditions. So now let's take a look at the results. We compared ViLi100 with a top global GNSS brand known for its high precision and reliability, and another latest conventional GNSS receiver from another brand. And in our internal lab, we conducted over 1,600 multipath scenery tests across all the neighborhoods, the forests, and high-rise environments. So in heavily obstructed conditions, ViLi100 achieved a 5 centimeters accuracy in 95.1% of measurements. It's 22.9% higher reliability than conventional GNSS receiver, which is just at 72.2%. So this isn't a small improvement, it's a fundamental shift in reliability. So on the screen, you can see repeated measurement at the same control point across different receivers, and in severe obstruction environments, ViLi100 maintains tight, consistent results while others clearly scatter. So this is why we confidently say confident and consistent accuracy in abstraction. Once right, always right. ViLi 100 is built for the environment where conventional GNSS receivers struggle the most. So with ViLi 100, now we introduced the second feature, the SFix2. Last year, SFix1 proved that reliable positioning in GNSS obstructed environment is possible, and SFix2 takes the next step. The key upgrade is simple and powerful, reliable 5 cm accuracy within 20 meters radius, even in fully GNSS denied areas. This capability is now built directly into ViLi 100, designed to measure points that conventional GNSS simply cannot. So let's take a look at a situation looking very familiar to many surveyors.
Fixed, let's go. As long as I run fast enough, the float solution can't catch up with me. Oh no GNSS signal anymore.
So to measure a point under a temporary shed, under an eave, or even under a bridge, surveyors often have to get fixed in an open area, sprinting, and hope they can press the button in just at the right time. We call this the self-deceptive survey method. It's more than a trick, it's a daily challenge because satellite signal at night and conventional GNSS just cannot get fixed, and the total station became the only option, but it's slow, heavy, and inefficient. With ViLi 100, this workflow changed. And this is another heart of ViLi 100. It's the all-new SFix2 engine, a true breakthrough for fully GNSS denied areas. And in areas with no GNSS signals, SFix2 can calculate the RTK coordinate using the 3D lasers, ranging data, and the SLAM-based angular constraints. So this is really much sensor fusion, and it is what sets SFix2 apart from conventional IMU integrated GNSS receiver. And I can introduce the difference to you. Like in a GNSS fully denied areas, traditional IMU RTK receiver is just like walking blind in the dark. Eventually you drift, of course. But SFix2 is like walking with a flashlight. LiDAR ranging and the SLAM provides continuously positioning and orientation. So even when GNSS signal disappears, you stay on the right path. So the result is that in areas where traditional GNSS receiver cannot get fixed, ViLi 100 keeps going, reliable, stable, and precise. SFix2 also brings major gains in positioning stability and fault tolerance. Powered by the next generation LiDAR scanning up to 860,000 points per second, the engine gathers rich inversion observation information and also greatly enhancing the SFix positioning reliability. And trade on the tens of thousands of scenarios tested with RS10 and SFix1, SFix2 has been extensively trained and optimized. And the result is simple, accurate, repeatable positioning, even in the most challenging conditions. For the end user, the experience is straightforward. With ViLi 100, surveyors can confidently measure up to 20 meters radius in fully GNSS denied areas while maintaining stable 5 centimeters accuracy. So no total station, no instrument switching, just the ViLi 100. Now you can trust every fix. And let's look at the real project result. Under bridge and overpasses, GNSS signal are completely blocked. With ViLi 100 repeatedly measurement in these areas, consistently stayed within 5 centimeters where compared with total station benchmark. So this level of consistency is what makes SFix2 practical in the field. And here is a case from our customer in Italy. Topographic survey in a fully GNSS denied areas. Normally, this would require switching to a total station. With SFix2, the survey was completely directly, efficiently, and accuracy. Let's see it.
È ovvio che in questo luogo dove ci siamo posizionati un sistema tradizionale GPS non avrebbe funzionato, ma come possiamo vedere dal display siamo in modalità SFX, abbiamo gli indicatori di precisione, quindi noi andiamo a fare le nostre misurazioni che ci occorrono per identificare questo luogo. Quindi nelle abitudini che ormai da anni i nostri tecnici hanno nella tipologia di rilevamento, andiamo a prenderci i punti identificativi di questa sala completamente al chiuso, che possiamo oggi misurare solo ed esclusivamente con la tecnica SFX del i100.
So with the SFX 2, we can now doing the topographic survey directly to measuring both the points in the field and indoors. And this is another common scenery, pipeline manhole surveys in GNSS denied areas. That's it.
Quante volte vi chiedono di poter posizionare i tombini lungo una tubazione? Questo contesto sicuramente è quello più ostile che potremo trovare. Andiamo subito ad operare con la SFX mode. Batto il primo punto, batto il secondo, vediamo il nostro tombino già posizionato nella grafica, entriamo completamente al chiuso, quindi possiamo ovviamente continuare a misurare. In qualsiasi posizione e in qualsiasi modalità. E ovviamente continuiamo all'interno per terminare la nostra misurazione. Ovviamente possiamo terminare le nostre misurazioni e completare tutto il tunnel.
Yes. So like from the video, and you can see with SFX 2, now we can easily measure the whole pipeline even when it's in the tunnel. So these cases prove that the all-new SFX 2 enables surveyors to confidently measure up to 20 meters in fully GNSS signal-denied areas without switching to a total station. So earlier we talked about the GNSS obstructed environments and the GNSS denied environments. And next, let's talk about construction work. For our construction and earthwork teams, everything comes down to three things: efficiency, accuracy, and safety. So traditional workflows struggle on all three, like point-by-point collection is slow and labor-intensive, and accuracy depends heavily on point density and post-processing, and our field operators are often forced into risky positions. So these challenges directly impact the project timelines and costs. And this is where ViLi 100 changed the workflow. With 3D point cloud earthwork calculation, ViLi 100 delivers real-time cut and fill results directly on site. Like first, accuracy. With ViLi 100, high-precision laser sensing combined with the Landstar app filters out noise and delivers real-time cut and fill volume calculations. And the next, the speed. We just scan, define the boundary, and get instant results, no post-processing. And finally, safety. ViLi 100 enables non-contact measurement. No need to climb pipelines or physically touch surface. Operators can stay safe while measurements stay accurate. So ViLi 100 redefines earthwork surveying, combining accuracy, efficiency, and safety in a single streamlined workflow. So later, our valuable UK partner, Mr. Ted, will also share his real case from the ViLi 100 about the 3D point cloud earthwork calculation. And also beyond the earthworks, many survey points are simply hard to reach or unsafe. And this is why we introduce ViLi contact survey, a safer, faster, and more reliable way to measure. And this is where ViLi 100 ViLi really shines. Like traditional contacting methods have clear limits. Like laser survey, it requires steady aiming and small shakes will mean big errors. And like visual survey, it required the on-site post-processing and workflow interruptions. So both impact efficiency and reliability. So ViLi takes a different approach. With the ViLi, it takes a photo first and capture points later and instantly extract the multiple 3D coordinates. And no need to aim to the target perfectly, no need to stay rock steady, no precise alignment with the range pole, and the ViLi contact survey is fast, stable, and user-friendly. And its 8-megapixel telephoto camera capture sharp visuals up to 50 meters. Even in complex, hard-to-reach areas, ViLi maintains 5 centimeters accuracy. So in short, ViLi contact survey gives you a safe, precise, and effortless way to measure the hard-to-reach and dangerous areas, overcoming the limitation of traditional laser and visual methods. So what you have seen today is only part of ViLi 100. As a true flagship, it also delivers everything you already expect from a professional GNSS article receiver in a compact device. Firstly, powered by Landstar, the field software trusted by over 500,000 surveyors worldwide. ViLi 100 brings familiar article workflows together with next-generation innovation, so teams can work faster with virtually no learning curve, and also with the AR visual navigation and visual stakeout. Stakeout efficiency can be improved by up to 50%. Testing field let our field teams work faster and smarter. And with the full GNSS work mode support and trip, the UHF-based and rover and PPP mode, ViLi 100 adapts to different job sites and different environments, delivering high precision results every time. And that is the ViLi 100 Visual LiDAR GNSS receiver. Let's recap its 5 game-changing advantages. So first, once right, always right, confident and consistent accuracy in abstraction. Next, SFix2, reliable 5 cm accuracy within 20 meters radius in GNSS denied areas. And the third, real-time 3D point cloud Earth calculation, accurate, fast, and safe. And fourth, the ViLi contact survey, take a photo first, capture points later, no need to aim or stay rock steady. And finally, all-in-one flagship GNSS receiver, every conventional GNSS features you expect integrated into a simple compact device. With ViLi 100, now you can trust every fix. And next, let's take a short video at the ViLi 100 in action.
Introducing CHCNav's new ViLi i100 Visual LiDAR GNSS receiver, redefining flagship GNSS with revolutionary innovation. Powered by next-generation 860,000 points per second LiDAR fusion, ViLi i100 accurately captures surrounding 3D spatial data in GNSS-obstructed environments, intelligently analyzes satellite signal paths, and auto-filters multipath errors caused by obstruction or reflection. Even in narrow alleys, dense forests, or near high-rise buildings, it delivers confident and consistent 5 centimeters absolute accuracy. No matter how many times you measure, your position stays right. Once right, always right. With the enhanced SVIX 2.0 engine, ViLi i100 ensures reliable 5 centimeters accuracy within 20 meters, even in GNSS denied areas, using high-density LiDAR data with SLAM-based angular constraints. Trained on tens of thousands of real-world scenarios, optimized for complex field conditions. No need to switch total stations. Experience true GNSS anywhere, even in GNSS-denied areas. High-precision laser sensing enables real-time 3D point cloud earthwork calculation. With Landstar software, just scan and define boundaries to get 99.98% accurate cut. Fill results instantly on site. No surface contact needed, combining precision, efficiency, and safety in one workflow. ViLi i100 supports ViLi contact with survey using laser data. capturing one photo to instantly extract multiple 3D coordinates with 5 centimeters accuracy up to 15 meters. Capture first, select later. No need to aim, stay steady, or align the range pole, eliminating hand tremors. The 8-megapixel telephoto camera delivers clear visuals even when zooming from long distance. With the latest Landstar software, ViLi i100 integrates all conventional GNSS features in one flagship receiver. CAD AR visual stakeout boosts efficiency by up to 50% and supports NTREP, UHF base rover, and PPP modes. ViLi i100 Visual LiDAR GNSS RTK receiver. Now, you can trust every fix.
Okay, so thank you for joining this deep dive on ViLi 100. And what you have seen today is the result of real field challenges, real feedback, real innovation. And this is just the beginning. And next, you will hear the voice directly from our R&D engineer, Mr. Jesse, and our valuable partner, Mr. Ted, as they will share real-world projects. With that, I will hand it over to our host, Ms. Cecilia. Thank you.
Thank you, Rachel. Incredible insights from Rachel, and those 5 features really showcase why the ViLi i100 is a game changer for field professionals. But behind every great product is even greater technology, and that's where JAS comes in. And JAS technology report is titled Multi-Sense Fusion, Enhancing Reliability of Accuracy in GNSS Challenging Environments. And he will unpack how we solved the age-old problem of GNSS signal blockages. Take it away, Jess.
Hello, everyone. Okay, I'll start my presentation. Hello, everyone. Good afternoon. I'm Jesse Chen, System Engineer for i100, and I focused on developing high-precision positioning and scanning products. Next, I will introduce SFIX, our advanced multi-sensor fusion technology developed by CHC Alkismus team. First, I will outline the survey challenges and existing solutions, then I will explain the SFIX technology and some detail, followed by our real scenarios testing and cases. Let's start with a widespread typical challenge. Common urban landscape, such as old residential neighborhoods, overpasses, and high-rise buildings, leave very few open areas suitable for GNSS survey. Then we have no choice but to resort to alternative methods, just like total station or rulers. To be more specific, signal blockage leads to inaccurate GNSS positioning. When the GNSS signals are blocked by 50% or more, positioning errors can easily exceed limited. And in case of even more severe sky occlusion, flood, or worse still, it can produce false fix that appear valid but are extremely inaccurate and is difficult to detect for user. Then we use the standard test, moving directly from an open sky area into the target environment. Different sky blockage present. The results clearly show that the level of obstruct has a significant impact on accuracy and stability. When the sky is heavily obstructed, positioning accuracy often fails to meet serving requirement. As we can see in the table, in severe blockage and medium blockage, and even more, it's difficult to know the level of blockage. Is real fix or false fix? What is the situation now? Is or and certainly an unknown. So, faced with these challenges, we have a very traditional solution, the optical measurement, the total station. Also, it's difficult to use and inefficient. It remains highly reliable and only trust choice. And now we have some modern approach, the non-contact measurement, the visual serving and laser serving. The visual serving limited by lighting condition, the surface texture, and viewing angles that make its accuracy hard to quantify. And the laser serving had error from handshake and less more difficult to see in most outdoor conditions because of the light. In comparison, I still prefer the contact-based measurement. I think it's more simple and more reliable. So, what makes multi-sensor fusion different from us and others, and why it solves our problem? That's exactly what I will introduce in this film. Multi-sensor fusion is already wide adopted and has greatly overcome the limitation of individual sensors. However, significant challenges still remain to be addressed. In multi-sensor fusion, just like the lossily coupled integrate of SLAM and RTK, suffer from fundamental technical challenges in half blockage area, drift, and noise in the RTK positioning system degrade overall system accuracy. We have confirmed this through simulation and real-world tests from the RS10. And this is also a common cause of scanning problem in the SLAM device of mobile scanning system. Our first generation fusion technology, the SFix1, is also used an open loop lossily coupled integrate of RTK and SLAM, as you can see in this picture. It established trajectory and misalignment angle to provide continuous positioning in obstruct areas and also the open scan areas. So it operates similar to a wide average system, always misled by the noise and errors. For our RS10, we rely on repeat filtering and reprocessing during the post-processing process on our computer to achieve high-precision fusion result. But this cannot meet the requirement of real-time survey. So, we bring out the second-generation fusion technology, the SFix2, employs a closed-loop tight copper integration of RTK and SLAM. As more complex as the picture, and its core, it performs continued optimization of all the multi-sensor observations within a uniform state space. This allows the system to dynamically evaluate and adjust each sensor's information and covariance in real time within iteration. To enable this, we have developed specialized RTK and SLAM algorithms for real-time fusion. As a result, we can continuously deliver accurate pulse across challenging environment. So what is the specialist algorithms? For example, the RTK algorithms for SLAM is specification designed to achieve ultra-high precision across all scenarios. We proactively blocked abnormal or inaccurate GNSS signals, just as a picture. Where this reduces the fixed rate, it significantly improves overall position accuracy. As you can see in the picture, the blue line is SFix and the green line is SFix RTK. It has some loss, but the accuracy will be better. It shows a key advantage of SFix2 multi-sensor fusion. The system doesn't rely on success rate of any single sensor. Instead, we can increase individual sensor sensitivity and let the fusion system ensure 100% reliable positioning. And in this new architecture, environment perception acts as a center hub. That is our unlost detect algorithms. It truly expanding the stability and the usability boundaries of traditional GNSS system. Why? Because we can capture surrounding and overhead point cloud to analyze. We have get a nearby building or tree canopies, and we analyze the path of each satellite signal. This allows us to automatically identify and exclude unreliable satellites caused by blockage or refraction. This capability directly addresses a long-standing RTK challenge, position jump and false fix in complex environment. And therefore, we request to capture complex and dense point cloud. But conventional SLAM device, as we all see, always have limitation in scan range. For example, a 60-degree vertical field of view leaves plain area. It cannot simultaneously cover both ground and tree or high wall effectively. To achieve complete capture, user need to planning a scanning path that is not for our GNSS user. And therefore, we chose more advanced and more costly hardware, a hemisphere LiDAR. Its ability to deliver complete dense point cloud with high rate that make the in-loss detect technology and our environment detect possible. And not only advanced tech, we also aim to serve our user with advanced technologies through simple and friendly operation. There are many small design details, and just for example, traditional SLAM initialization requires 3 steps: the LiDAR initialization, the static initialization, and a dynamic alignment from SLAM and RTK. And in Construct, our SFix2 completely redefines this process. Initialization is now complete while continuous moving. You don't need to stop, no static process, everything in a moving step. This is a brief introduction to our SFix technology and algorithms, and I hope you all find it interesting. So at WAR, we need to extensive testing to demonstrate our SFix outstanding performance. We have collected data from over 400 control points, that is also from the total station calibration, and specifically include the challenges scenarios such as end bridge and double-side buildings. Through extensive testing, we have delivered these similarly dry percentages, but they clearly demonstrate that our SFix2 delivers significantly better stability and higher accuracy under multiple conditions. As you can see, this dry percentage from many points, many tests. So finally, let me briefly introduce a typical use case for the SFix. Firstly, we should find the environment and get a good price that is almost open sky area, and we can guide a high precision RTK position, that is start base, and then we can use SFix to survey. And if you say float appears, just move back to any open sky area and get a new position. We will do it underground. There is also a little tip. If you get a float, but in SFix startup, the accuracy of float is slowly decreased with distance, mostly enlarged by 5 cm per 15 meters. That is not like the traditional RTK. In traditional RTK, when you get a float, there is also a fly point, it's meter change, but in SFix, it's just different. So thank you very much for your listening. Enjoy high efficient survey by ViLi i100.
Okay, thank you, and brilliant technological dive from Jess. And now we all understand the how behind the ViLi i100's accuracy. But what does this mean for real users? That's the question Ted from Treeside is here to answer. As our trusted UK partner, Ted and his team have deployed the ViLi i100 across various projects, and he will be sharing those on-the-ground success stories with us today. Let's hear from Ted.
Hi guys, thanks for having me today. I'm just going to present my screen now. Can you all see that okay?
Yes, perfect. We can see your screen now.
Right, so obviously we've been using the i100 now for a few months, and we've seen a lot of success with it. Obviously, there's lots of reasons to have these units, and I think the more people use them and the more they see them, the more they realise that the benefits of having them. But one of the main benefits that we've seen with the i100 is the ability to carry out stockpile surveys and earthworks measures with the unit. So obviously stockpiles, especially problematic stockpiles. So if you look at the pictures here, we've got pre-crushed concrete, we've got some pre-crushed aggregates there, and we've got what is a very messy earthworks site on the bottom. So the challenges that come with stockpile surveys are obviously they're not a simple surface. So by that I mean they're irregular. They're rough, they're often unsafe and dangerous. For example, you wouldn't want to walk as a surveyor around those top two pictures. So there's safety concerns with them. There's the irregularity of the geometry that's on them. There's also the time pressures. So many times people, they want, especially in construction, they want results. They want results there and then, or they want results quickly. And then obviously accuracy expectations. If you were to actually survey these stockpiles, there's many ways of doing it, but what is the expected accuracy? Where do you think it will be? And so these are all problems that we face when we're measuring stockpiles and earthworks. So obviously there's the traditional methods that we've all used sort of so far. There's the UAV, which photogrammetry or LiDAR. It's a fantastic option, and it can cover huge areas very quickly. But there are downsides to it. There's downsides such as the processing can be very lengthy. So there's costs involved with both the processing and the training. There's quite a heavy investment in the hardware. The drones aren't cheap. The LiDAR units aren't cheap. The photogrammetry software is not cheap. So the UAV option is a great option if you've got large areas to cover and you don't have timescales or particular timescales involved. So yeah, it's good. Then you've got your GNSS rovers, whether you're running it off a base station or a N-trip. Great option, doesn't rely on line of sight, can cover great big areas. You do have to walk the full stockpile, so you have to walk the top and the bottom of the stockpile. So there's some downsides there, especially when you're dealing with stockpiles like I showed you in the first images. But again, you are not picking up all the detail. You are relying on a person picking up and surveying what they think is the important detail. So quite often areas are missed, so you're not getting the full picture of the stockpile. And then you've got the total station, highly accurate, but then suffers with the same problems as the GNSS rovers, as in you don't pick up all the detail, you just pick up what the surveyor chooses to survey. But it also, because of the ability, it needs to have the ability to see a line of sight to the prism. It's fine for small areas and small bits of job and flat terrain, but when it comes to doing large stockpiles, it isn't an efficient tool. So they're the options that you really have at the moment. Great options in some ways, but they do have a lot of downsides as well. So then we look at this. So why has the i100 become a bit of a favorite of ours and our clients? Well, it allows us to capture data on the fly. So we can go out and pick up all the detail with just by walking in a safe area. You have a range of sort of up to 30 meters, and you can pick up all the detail in one go. You get a high density point cloud, so it's not too dense, but it's dense enough that it picks up all the detail that you would expect it to pick up, same as any scan unit. You can also use it for obviously picking up remote points, like we saw with the visual LiDAR. And if there was something of interest that particularly needed a particular coordinate on, you can actually point that off. So that's a massive advantage. It's repeatable, so you don't need any targets. It's a fusion of GNSS and LiDAR together, and it is repeatable. So you can go out to site and do the same stockpiles day in, day out, day after day, hour after hour, and you will get the same results each time without any targets required. It'll run off obviously UHF or off a base station on UHF or on Entry. And simple workflows as well. So with all SLAM technology, the idea behind it is that you need overlap on your data. You can see here on the slide, you can see what we call a stockpile yard, a stock yard for an aggregate company. You can see the purple line is the trajectory that was walked. The idea being that you can get plenty of overlap on your point cloud, back and forth. And you can see as well on there that there is actually buildings involved. So the LiDAR unit, the i100 unit, has actually come round the stockpiles and through inside, as per the image at the bottom left-hand side of the screen shows, and actually walked through the building on the inside. So there's no need for any total station, no need for any target. It's just switch to SFix and literally walk through inside the building, no problems, and maintain that fixed position. So it really is a fusion of LiDAR and GNSS. You can have it on a detail pole, or we've also had it mounted on a harness, so you can actually have it on a harness the same as the RS10, and it's only one person operation, so there's no need for, or very little need for, any training, and it's very, very simple, very simple to use. It's just literally a case of walking around the piles, capturing all the faces and the toes, closing the loop is what we always recommend. And then you can see there, that's the sort of point cloud that gets delivered off the unit at the bottom. It's a high density point cloud, but at the same time, it's still manageable and not too big that it can actually be zipped and emailed. You'll see this whole site shortly when we show you the video, and I think the point cloud was less than 50 megabytes, but still contain millions of points. So you still get the detail, but you don't get the super large file that really for stockpiles and earthworks isn't actually necessary. But with the UAVs, etc., you do tend to get that. The volumes can also be calculated in the field. So if there was a requirement for a stockpile to be actually calculated in the field, you can actually do that on the controller and produce a PDF report and everything as you go. So you can see here some of the an output from a pre-crushed concrete stockpile. It's quite large. It was around about 14,000 cubic meters. You can see the top two images of the point cloud. You can see it's very rough, quite undulating. There was an area where it could be walked on the top, but it was very minimal. It couldn't be walked across the full width. So you can see at the bottom left-hand side now, you can see DTM, or the triangulation that's been formed from the point cloud from the i100 unit, and you can see at the detail that's been formed from that, and every little undulation and every little piece of that stockpile has been collected and recorded. On the right hand side, you can see what we call a traditional survey that was done with a GNSS unit. You can see that the difference between the two is quite significant. The GNSS unit obviously only records what the user tells it to record. So because of the nature of this sort of stockpile and the fact that it's unsafe to walk on, then the user was unable to get any more than the top and the bottom of the embankments on all the sides. So there really is a significant difference between the left-hand side and the right-hand side image on there. So to take that further, we ran some sections through this stockpile. There's a section in each direction, and you can see on the section image below the actual image of the stockpile, you can see a long section, and on that section there's the dark line which corresponds with the point cloud. So you can see the cyan blue point cloud in the background, and you can see the black line which follows that precisely, and that is the DTM which has been formed from the point cloud from the i100 unit. Below that, you can see a pinky reddy color line. That is the GNSS unit. So you can clearly see on the batters, so on the embankments, that the toe of the batter and the top of the batter, or the top and bottom of the embankment, is in the correct place, but everything else in between is missing. And you can also see that on the right-hand side of the top image on the section, you can see that the toe of the embankment doesn't tie in with the toe of the embankment from the scanner. And the reason because of that is because the person who was doing the surveying has picked up a point here and then moved along another 10 meters and picked up a point there, but has actually missed the fact that the embankment curls in. So the i100 picks up all the detail. Traditional surveys just miss it, and you can see it again on that bottom image. The top and the bottom of the embankments are probably where they should be, but everything else in between really is completely different, and that is because the i100 is picking up millions of points per minute. Traditional survey isn't. So again, we moved on to this same stockpile. You can see there an isopachite being a height difference model. It shows the difference between the data captured between the traditional topographical survey with the GNSS rover and the i100 unit. And you can see there the height, and you can see the key on the right hand side. There's differences of up to 1.5 meters in areas. And that is not because the GNSS is less accurate, it is just it does not pick up the same level of detail that the i100 does. The i100 captures everything, the GNSS unit doesn't. And on a 20,000 cubic meter stockpile, we've estimated that some of the calculations that we've done on some of these sorts of stockpiles, there can be up to as much as 10 to 15% out in terms of accuracy. So a 20,000 cubic meter stockpile could be out as much as 2,000 cubic meters. So what are the advantages over other methods? So minimal training required. The i100 unit and Landstar software is a super intuitive piece of software and equipment. So very little training. It's only one operator, so there's no need to have two people using it. It's one operator. There is no special software of post-processing. Everything is done in the field. It is done by the i100 unit. It is downloaded across Wi-Fi onto the tablet. It's super easy, super slick. There's no flight permissions or delays due to bad weather or wind. So you'll see in a video shortly where a client of ours was using it on a stockpile yard, and it was a very wet and a very windy day, and that is why they sent us the video, and it meant that they could capture all the stockpiles in that yard. And I'll tell you the time it took shortly, but in a lot less time than it could take to carry that out with a UAV or just a standard GPS. It works in GNSS denied environments. So the stockpile that you can see in the background there, this was done for a demonstration to a client who purchased an i100 unit. Now, this particular stockpile, there are a line of trees down the right-hand side. You couldn't have surveyed to the bottom of the embankment with a traditional GNSS unit. You would have struggled with a UAV to do this. This stockpile took 3 minutes to record that data, just 3 minutes. It was simply a case of walking up onto the top of the stockpile, walking around in a loop on the top of the stockpile and back down, and it took 3 minutes to capture this data. That is how fast this is. And 3 minutes, and you've got a LAS file on your controller that can be zipped, compressed, and emailed straight back to the office as a LAS. No post-processing required, all geo-referenced, and it's ready to go. So it's a very, very fast turnaround of data, very fast method of capturing data. So you've got, imagine it, you've got the detail of a UAV survey, you've got the ease of use of a GNSS rover, but you've got speed of probably up to 10 times faster than any other method of data capture. I did make some notes on that, but I seem to have lost those. But if you were to survey that stockpile with a GNSS rover, or in this case a total station, you'd probably be looking at least half an hour, maybe 40 minutes to have surveyed it all with a total station. 3 minutes is all it took to do that particular stockpile. So it is a super fast unit. So from a cost and investment benefit point of view, you've got a reduced capital input. So there isn't the capital input that's required for an i100 unit isn't even as much as a high-end UAV. So you've got less capital. There is no special software required for post-processing, so there's a saving there. There is no license required, so there's a saving there. So yeah, so it's a very small capital investment compared with other methods of mass data capture. There's no reoccurring post-processing costs because there isn't any. You've got a very fast turnaround of surveys on site, so you get instant results on site very quickly. So you can do multiple stockyards in a day, multiple stockpiles in a day. There's very little. There's no turnaround on the data. It's literally instant. Zip it up and send it across on an email or upload it to the cloud and keep working. So it quickly pays for itself. You've got basically a lot less capital outlay and total cost of ownership. More surveys can be completed in a day, so there's a small financial outlay compared with other options. So lastly, this is a video of the stockpile yard that was shown in the images. It took less than 10 minutes to do this. So even if you'd used a UAV to do this, and I know there'll be people out there saying, oh, we could just use a drone. Yes, you could use a drone, but you couldn't have used a drone on that day because it was too wet and too windy. So you wouldn't have been surveying there. It took less than 10 minutes. It would take you more than 10 minutes to get your GCPs out. And as you can see, you've got all the detail that you'd get from a UAV, but in 10 minutes, instantly, LAS file and moving on. So from the time that surveyor got to site, it took 10 minutes to literally walk that full area and have a LAS file. There is no other method of data capture for volumetrics as fast as this on the market today. There just isn't one. Even if you used a traditional SLAM scanner, even the RS10 isn't as fast as this because you've got the post-processing. Yes, you would end up with a denser point cloud, but this unit for this method of work is outstanding. Volumes in the field, if you need them, on a PDF report, and various options on that as well for volume. So you can do surface to surface, you can do stockpile volume, you can do anything you want. So it's got proven advantages over traditional methods. And yeah, it's a game changer. It's not just it's not just another GNSS rover. It is an absolute game changer for this sort of work. Thank you. I'll hand you back to our host.
The voice. The voice.
I think Cecilia's got a microphone turned off. Wrong.
Yeah.
Can you hear me now? Okay. So if you didn't hear, sorry about the technical problems. Okay. And thank you, Pat. And then for real world examples, and then it really brings the ViLi i100's value to life. And now it's time for our Q&A section. And we will be collecting the questions from the audience in the chat box throughout the webinar. And then we will pick out the most popular ones to address. And let's start with the first question. So the first question we got is, will it be possible to obtain a classic point cloud in the future, like with the RS10 but less detailed? Maybe Jess, could you please address that question?
Okay, can you hear me? I think it's absolutely yes, and there's now, not future, you can get point cloud data directly from the device storage. And now, and right after scanning is finished, we have specifically optimized this for earthwork and similar application at about 3 to 8 centimeter 1 point, which just right for faster and accurate volume calculation. And even better, you can download and process the data directly in Langstar. Volume result in just a few minutes effective. And if you want, you can also download the last file from the Langstar application and make a document or use your own application on your computer. That is all possible. Okay.
Okay, thank you, Jess. And so we go to the next question, and then the next question is the difference between the ViLi i100 and the RS series. Maybe Rachel, could you please stress that one?
Yes, I think it's a very frequently asked questions, because when we demonstrate ViLi 100 to our partners and to our end users, they always ask, what's the difference between ViLi 100 and your previous RS series? I think I can divide it into like two parts, like from product positioning and also the product application. So like for the product positioning, while both the ViLi 100 and RS series can capture the point clouds, yeah, just now our audience also asked this question, but our ViLi 100 is positioned at our C2C NAV's flagship visual LiDAR Gen SS receiver. So its core value is the multi-sensor fusion positioning, like the Gen SS integrate with the LiDAR and the multi-visual and also the ultra IMU technologies. So it can ensure like high reliable accuracy even in Gen SS obstructed and Gen SS denied areas. And its point cloud capability is used as a tool to support for like the value calculation, like the earthwork measurement, and also like some road cross-section extraction. And also the point cloud were also used in the unlost algorithm, just like the Mr. Jesse introduced when we use our SFIX2 engine to scan the surrounding spatial temporal information, it will automatically detect the surrounding, like the point clouds from surrounding buildings, and then analyze the satellite signals and intelligently feed out those unhealthy ones. And but for our RS series is a dedicated handheld LiDAR scanner, so it's a product strategy centered on the point cloud capture and also the post-processing, like it extended into the software-based service such as like the colorized model generation, the night drawing, and the DEM extraction, and also the 3D mapping workflow. This would cause the different application series. Like our ViLi 100, it can design for some outdoor field work, and it can be extended to up to 20 meters radius in GNSS signal denied areas, and like in some urban cadastral survey, some boundary mapping, and some obstructed areas. And it can also support for other like conventional GNSS etiquette features like the CAT AR visual stakeout and also small to medium scale value calculation. And for our RS series, so with its much longer scanning range and also the higher coverage, and also it's the higher point cloud density, so it's designed for some large scale non distance and high efficiency scanning projects. So like some in infrastructure corridors, like mining sites or some extensive terrain modelings. So that's the difference between the ViLi 100 and our RS series.
Thank you, Rachel, for the really detailed answer. And then before we go to the next question, I'd like to point out for audience who are online, please, here is a QR code, and you can scan on the right top of the corner. And if you have questions, or if you're interested in our ViLi i100, or if you're interested in anything related to it, please leave a quote and please send us a message, and we will contact you soon. So let's go to the next question. So how much improvement in efficiency and accuracy does the ViLi i100 offer compared to traditional GNSS receivers when it comes to the earthwork surveying? Maybe Tad, could you please address this question?
Yeah, I'm more than happy to answer this. If you look back to our example there, and the stockpile survey that I showed you of that yard, our client estimated that stockpile survey in there, if it was done with traditional methods such as a GNSS rover, and you would need to use a total station as well, you would be looking at around about 4 hours of work to capture that site. You would then have to carry out probably an estimated 1 hour of processing to make sure the data was correct before it was ready for volume calculation. So probably around about 5 hours of work to capture and process that data. That survey on the video was done in 10 minutes. 10 minutes from start to finish. And the data, as long as you've got software, which most modern surveying practices do have software that can handle point clouds, I will make that, and we are making that assumption. If you don't, then there's lots of options out there on the market, but from 10 minutes from turning the rover unit on to turning the rover unit off, LAS file downloaded, ready for volumes. So that's how fast it is. So you can do the maths on it. 10 minutes compared with 4 to 5 hours of work. That's how fast. It's at least 10 times faster than traditional methods for stockpile survey. You've got a range of 30 meters. So even the largest of stockpiles, you could actually capture the full face of the embankments. Yeah, up to 30 meters. So you really, it's a game changer when it comes to that sort of work. There's nothing else on the market that can capture data as fast and turn it round into a usable format, ready to go, as this unit. There isn't anything. A drone is not that fast. So traditional methods, it's at least 10 times faster. Yeah.
Okay, thank you, Ted, for answering that questions. So I think we are about the time of ending this seminar for today. So thank you for everyone answering the questions, and we've covered a lot on the ground, and I hope that people got the answers that they were looking for. But sorry, we cannot cover all the questions, but as I said before, if you are interested in our ViLi i100, or if you have any questions or curious about this product, please scan the QR code before we end and get the quotes and send your inquiries to us. And then to wrap up today's webinar, let's extend a huge thank you to our amazing panel, Rachel for breaking down the product's value, Jazz for demonstrating the tech, and Ted for sharing those invaluable real-world insights from the tree side. And then a special thank you to all of you for joining us today. And we hope this deep dive have given you a clear picture of how the ViLi i100 can transform your field operations. If you have any follow-up questions, feel free to reach out to CNAV or our local partner directly. That's a wrap-up for today's ViLi i100 deep dive webinar. And thank you again, and have a great rest of your day.
Thank you.
Bye.
Goodbye.
Okay. Thanks.
Bye.